Now starting with the next problem on cone. A cone diameter of base 60 mm and height 70 mm has one of the generators in the HP, and the plane containing the axis and that generator makes an angle 45 degree with the VP. Draw the projections of the cone when the apex is away from the observer. Okay. So if I want to keep one of the generators in the HP, so initially I have to assume that the entire base of the cone, which is circle, entirely lying in the HP. So in that case, I need to start from the top view, drawing the circular base below XY line. Then only I'll be able to keep the generator on the HP in second stage. So first marking the XY line, then the base diameter is given as 60, so we'll keep the radius 30 mm and we'll draw the top view. Okay. Now next step is to divide the circle into 8 number of parts to get imaginary generators. So first marking the horizontal diameter, then dividing the circle with respect to this. Center is here. So marking the angles of 45, then 90, then 135. So first, then 90, then last division. Okay. Now I'll number those divisions starting with 1, 2, 3, 4, 5, 6, 7 and 8. Then 4 center of the base and apex. Now we have to mark the axis length of 70 mm. So I need to produce the vertical diameter for that, and I should mark 70 mm axis length. And obviously axis will be shown as long dash, short dash, because no slant edges will be coinciding with the axis here in case of cone. Now we'll project from other points on the circumference up to XY line to mark the imaginary generators in front view. So here 4 and 6 will coincide, 5, then on the opposite side 2 and 8 will coincide, and finally 1. Now we'll join the boundary with dark line, then 4, then base. We'll give the notations. Here it is 1 dash, 5 dash, O dash, O dash, then this is 2 dash, 8 dash, 3 dash, 7 dash will coincide with the axis, and 4 dash, 6 dash. So I'll draw the imaginary generators with 4 dash, 6 dash and 2 dash, 8 dash. Okay, so this completes the first stage. Now in second stage, one of the generators is in the HP. So here that outer generator O dash 5 dash in second stage I have to keep it in HP, means the entire front view will be rotated with O dash 5 dash entirely lying on the XY. So I'll in that case I have to keep one of the points on the circumference still in the on the XY line. So that point is 5 dash here. So I'll keep 5 dash on the XY. Now I'll mark the length of the generator, O dash 5 dash, because that generator we need to keep entirely on the HP as given in the problem question. So this will give me O dash. Now we'll complete the triangle by marking O dash to 5 dash, sorry 1 dash to 5 dash, arc for 1 dash, then again O dash to 1 dash, this will be same as O dash to 5 dash. So we'll get the outer of triangle 1 dash here. So we'll complete the triangle with dark boundary. Now again we need to mark the imaginary generators and axis. So from 5 dash, we'll mark 2 dash 6 dash, and again from 1 dash also I'll get 2 dash 8 dash at the same distance. So from both the corners I'll mark those points for imaginary generators. Then one more line for center for axis. That will be same distance from 5 dash also. Okay. So now I'll show imaginary generators. And then the axis line. And now we'll complete the corresponding top view. Be careful while drawing the parallel lines. Sorry, I forgot to give this notations. So after 5 dash it is 4 dash 6 dash, and 3 dash 7 dash 2 dash, and 2 dash 8 dash. Okay. So now continuing with projections. 2 dash 8 dash, then 1 dash, and finally apex. Similarly, now projectors from the top view parallel to XY. So first 7, then 6 and 8 will coincide, then the center line 1 5, then 2 and 4 will again coincide, then finally 3. Okay. Now we'll look at the corresponding points. So 5 will be here, then 4 and 6, 6, 4, then 3 and 7, so 7, 3, then 2 and 8, so 2 will be here, 8 will be here, and finally 1. Okay. Now apex and then center of the base. First we'll join 1 to 8 to draw the ellipse by smooth lines, smooth curve, not straight lines. Initially making it light, then we'll decide which part of the ellipse should be dark. Now observer will look from this direction. For the observer, the entire base is visible, which is ellipse, so the entire ellipse will be dark, because for observer this part is visible from the top. So the entire ellipse is dark. Now we need to just mark the boundary from the apex up to the tangent point. So this will give me the boundary for cone. Okay, and then finally marking the axis OO by long dash and short dash. Please don't join other points on the circumference to show the generators, because those are imaginary generators, no need to show those lines. Now moving to the third stage. For redrawing this top view, I need condition with VP now. Okay, and that condition is the plane containing the axis and that generator makes an angle 45 degree with the VP. Now here the generator is O dash 5 dash and axis is OO. So in the question they are talking about this line O25, because this line contains that generator also O25 as well as axis. So it is nothing but, that line is nothing but the plane containing both axis and the generators. So in next stage we need to rotate this O to phi line inclined at 45 degree, okay, to the VP. But while doing this, we will follow the rectangle method again, this rectangle. So if I want to make this line inclined at 45 degree to the VP, so if I start with this boundary of the rectangle inclined at 45 degree, then obviously after drawing parallel line, I'll get this line also at 45 degree. But again, while tilting, we need to decide the direction of rotation, because the position of apex is away from the observer. Because for final view, observer will look from here, and the apex should be away from the observer. Away from the observer means nearer to XY line. So I need to tilt this top view, entire top view, in anti-clockwise direction, so that apex will go nearer to XY line, means away from the observer. So we need to tilt like this. So first I'll mark 45 degrees. So if I want to tilt like this, so I'll mark 45 degree angle in this way and not this way, so that this line will become inclined in this direction. So first, so that that plane containing generator and the axis will be inclined at 45 degree. So I'll mark some point here, and with respect to that point, I'll measure angle of 45 degree, and on that we will mark the boundary of the rectangle. So 45 degree. Actually, we can take it closer, because nothing will come above this line. So no need to waste this much space in between. So we'll take this parallel line, so that will be again 45 degree. So we'll take this 45 degree angle here. Okay. Now, if I fix this corner here, then nothing will come above that. Now I'll take this distance. Actually, this corner should be here, because we want to tilt like this. So after tilting like this, this will coincide here. So obviously we are taking this distance to mark this opposite corner now. Okay. So my maximum redraw view will be here, so it will not coincide with the second stage. Now again I'll draw two perpendiculars from each division, 90, to mark the other sides of the rectangle, then 90, and on these sides I'll mark the remaining two sides of the rectangle. Means we have already marked the length of the rectangle. Now we'll mark the width of the rectangle perpendicular to the length. Okay, so which will be same for both the lines. Okay. Now after completing this rectangle, now we'll locate the points inside. Remember, we are tilting like this. So first I'll mark the midpoint, which is 5 from this corner. Now this corner is nothing but this corner after rotation. So first we'll mark the center line, on which we are going to get 3 points. First is 5, then 2 O's, that is center of the base and apex. Now this will be O, this will be 5, and for marking 1 and O, I'll get 1 here from the apex. So this will give me 1, and center of the base. So one more O. No, sorry, O. So this is 1. This point is 1, and this point is O. Now, from the parallel line through O, I'll get 3 and 7 on the boundary of the rectangle. So if I draw a parallel line through O, okay, this point will be 7 and this point will be 3. Now we need to mark 2, 4, 6 and 8. So for that, we'll first draw these two parallel lines, and for those lines we will take the distance from this apex. for 2 and 8. We have already followed this method in previous two problems. So one parallel line will be here, and another will be for 4 and 6 here. So here. Now after drawing these two parallel lines, we need to plot 4 points on that. 4, 6, 2 and 8. So first parallel line and second parallel line. Now for marking all the 4 points, we can mark all the 4 points with same distance, because from the center line they are at the same distance. You can check it here. So they are at the same distance due to symmetry. Okay. So we'll mark all the 4 points with the same distance. So from this center line, we'll cut 2 arcs, one on this side and one on other side. Similarly, for this parallel line, the same distance is there. Okay. I will give the notations. So after 1, here it is 2, 3, 4, 5, 6, 7 and 8. They are in order. Now I will join by smooth curve and entire ellipse is dark. Six is here. Then 1 to 8. Okay. I think something is wrong. 2 to 1, the distance is okay. Yes. Okay, it's right. So join by smooth curve. Entire ellipse is dark. Okay. Now finally, joining with the apex, the tangent points. And then between 7 and 8. Now this completes the redrawing, which needs that O to 5 line to be inclined at 45 degrees. Now if I extend this, you'll get that angle here, which is 5 equal to 45 degrees. Now we need to complete the remaining stage, final front view. So for that, we'll project from respective points, starting with, okay, first is 7, then 6, they are just slightly different. Okay, then 5. Sorry, the scale is getting tilted. Then 5. Then 8 is slightly inside 5. Then O. Then now again for 4 and 1. I think they are coinciding, 4 and 1. Then 3 and 2. I think again coinciding. And 1, 2. Okay. Now we'll drop from front view. Four dash 6 dash 3 dash 7 dash O dash 2 dash 8 dash and finally 1 dash. Okay. Now we'll mark the points. First is 7, so 7 dash is here. Then 6 dash is here. then 5 dash is on the xy, then 8 is here, 8 dash, then 4 center of the base will be here, then 1 and 4 on the same projector, so 1 is at the top, 1 dash, and 4 is here, 4 dash, then 2 and 3 again on the same projector, so 2 is here and 3 is here. Now finally the apex is on the xy, 2 dash. Okay, now we'll join 1 to 8 in sequence with smooth curve first, then we'll decide the visibility. If your freehand drawing is not good, you can still use French curve. Now after this, I'll first draw the tangent points, tangent lines. So first tangent is nothing but the xy line, and second tangent is at 2, I think, right? Then we'll also show the axis, then we'll decide the visibility of ellipse. Now first the part on the boundary, starting from this point, is dark up to this point. Okay, now we need to check for 5, 4, 3, 2. If you see 3, 4, 5, okay, that part from the observer points of view, then that is visible to the observer. I'm talking about 2, 3, 4, 5, that part is nearest to the observer, so that should be dark here. Okay, so this completes the solution for this problem. In addition to this, we will show the dimensions. First is diameter is 60 mm, then the axis height is 70 mm, here the generator is lying on the HP, so no need to show the angle. Here the angle is already shown 45 degrees. Okay, so this completes the solution for this particular problem. Ask the name 14 for 15 marks.